Now I'd like to talk about agile engineering practices. I want to bring up our asterisk here because Scrum by itself does not prescribe any engineering practices. It's very agnostic to the actual technologies or engineering activities that are going on. But I often see Scrum fail when places adopt it, and even if they adopt the Scrum process very well, but they don't adopt good engineering practices, they'll just put out poor quality products. So I want to make sure you think about some of these engineering practices. Even if you're the Scrum Master or the product owner, it's good to be aware of them because you want to be able to respond to the team when they start talking to you about these type of practices and support them. I used to be a developer, and I know how hard it is to not want to do more. I used to think there was no problem I couldn't cure with more code. The problem with that is we tend to want to build these huge frameworks and sacrifice features. So if you think about a common layered architecture to an application where you have the presentation layer, which is the UI, services that are exposing all of this to multiple UIs, some business logic layer with all the actual calculations and those type of things, and then the data layer where all the data is stored. And what will happen is a lot of developers want to build these great platforms that will solve all our problems. So when we start a sprint, they might want to build a WCF service bus that will be able to handle any call we have coming in from an outside client. And then somebody wants to build this great entity framework for the business logic to represent all the business entities and all the logic in them. And they're building this great framework that will encapsulate all the logic we ever will have. And then the UI guys want to build this beautiful, Windows presentation foundation app that has the ability to plug in anything we'll ever have and solve all our problems. The database guy wants to create this great SQL database that will have everything we'll ever need and hold all our data from now until the future. The problem with this is that if this is where we ended our sprint, I don't have anything I can actually show a user. I have a bunch of frameworks, but unless that's actually your business, that doesn't help the end customer. And you'll spend a lot of time building stuff for the future that may never happen. Because you have to remember, the future is made up by salespeople and guidance counselors. It doesn't exist. Do the simplest thing that'll work for right now. So back to this layered architecture, you want to build a feature, register a new user, and you build just enough presentation to get that done, just enough service layer to service that, just enough business logic you need to create that new user, and just enough data to store the minimum data you need for that. You still want to build it in a way that's extensible, and that's something called emergent design that you can check out on your own, which is worth its own presentation in entirety. But you want to make sure you build just enough to get the job done. Then we build our next feature, login. Then we start building search catalog and we don't get all the way through. But at the end of the sprint, I have 2 fully functional features that we can show to our users, can even deliver to our users. It's just search catalog that get done. So working in this way where you're actually building through all the layers, the simplest thing that can be done, making it extensible in case we do have to build more, because you will. And you should make sure that the design and the architecture is just as extensible as the change we're going to have in the requirements. Since Agile is all about embracing change, you have to understand that your architecture and design may change as well. And you might have to go refactor things and extend them. If you adhere to emergent design and all the practices and principles of good engineering in software, that should be easy to do. I also want to talk about the YAGNI principle. YAGNI stands for you aren't going to need it. Or, I'm from the South, you ain't going to need it. And what that is when a developer is developing something and you say, I need a simple screen to capture contact information. And the developer starts developing this and he starts thinking, what would be great? I could write some service that it would expose this to other places that need to handle contacts. And I can also make a great import feature that could export from Outlook or whatever, and I can import those, and you wouldn't even have to use this screen. Then we can put on a mobile app. That'd be even better. And then we'll add geolocation so you can see on a map where all your friends are. These are great, but what we are asked to do is make a simple screen to capture contact information. The product owner needs to make decisions on all these other things, on where they are and how important they are. Don't put in more stuff than you're going to need. This is at the feature level. This is also at the technical level. You might say, oh, I want to build this really great generic engine that will be able to handle anything. And a lot of times when you build something like that, all you're building is more moving parts that can break. We want to make sure things are loosely coupled so I can put in something simple, replace it later with extended, whatever I need to do in the future of that functionality. But concentrate on meeting the need now and not gold plating something. Another practice you want to make sure you're adhering to is code reviews. Especially when you have multiple Scrum teams that are working on the same code base, it's easy for them to get lost in their own little world and start building things to their own preference rather than what needs to be consistent for the entire enterprise. So these can work out many different ways. It's where somebody's written some code and they need to go in and check that code against all the functionality that we've done before and that it follows these consistent practices. So you want to make sure that you do have some well-published and well-known coding standards. And coding standards can be things like where you put your curly braces and things like that. That should be pretty rudimentary. But you also want to talk about what patterns do you support? What anti-patterns do you not want to do? How do we handle these type of errors versus these type of exceptions? These are things your team should know and agree upon. And then when you do a code review, you really want to look at how the code actually performs. Don't worry about whether you're using underscores or how they're doing their names. You can use software packages that will determine that for you. Look at something and say, you know, this is going to hit the database 50 times in one call. That probably can be tuned to make one call or two calls and be more performant. That's something that should be brought up in a code review. Or the way you've coupled this item to another item is very tightly coupled. And we ever have to remove this and refactor it, it would be really hard to do and we'd have to change a lot of code. If you just use this pattern, like a abstract factory pattern or something like that, it would be easier to do. That is the point of a code review. I like to make them as informal as possible. So you might say, hey, I'm ready to check this code in. Raise your hand to your team and say, I'm ready to check the code in. Can you come and help me out and take a look at it? It may be as informal as that. You may also be doing pair programming where you actually have an implicit code review right there because somebody's helping you write this code. Sometimes you may need something a little bit more formal for many reasons. Sometimes teams are too big, or you have very junior members on your team that really would not know what to look for in some of these code reviews, so you have to have a select number of people that actually do them. And there are tools that will allow you to do code reviews and trigger it after a check-in and things like that. Try to keep it as informal as you can. If it has to be formal, that's okay. Sometimes you need that. But also try to make it a learning experience, not a I gotcha. Don't come in and say, hey, you didn't do this right, or you didn't do that right, or this is wrong, and what were you thinking? It needs to be, can you explain why you did that? And can I maybe tell you a better way? You want to have a good attitude about it. I worked with a gentleman who, when he did a code review, would walk by my office and say, hey, you want to go make the junior developers cry? That's not necessarily a good attitude. The code review is a learning experience to help us make the code consistent and of good quality. Now I'd like to talk about technical debt. This term comes from when you have to make shortcuts in technology to meet a business need, and you want to mark down that this is something we did that might hurt us down the road. This is a great thing for both sides of the fence, the business and the engineering people. So business comes and says, we need XYZ in a month. And the developers come back and say, there's no way we can do that. If we build everything the right way, it would take too long to do that. And there might be a critical business need. There might be a conference coming up that if you can't demo this to your customers, you're going to be leapfrogged by everybody else. There are real business needs, and there can be a negotiation. And what you can do is slim it down to what will get in that time frame, and all the things you wish you could have done, note them. Put them on a backlog. Put them either on your product backlog or have a separate technical debt backlog where you say, I normally would have liked to have a really good administrative backend for this where you could add these things in and out through an interface, but now we made it through a script. And you've noted it, we've moved on, and we can always revisit that if we need to. And when you mark down technical debt, you want to say things like, this is what I would have done, this is the benefit it would have given me, here's things that it would cost, because there's always a cost to it, and here's smells. Smells are things you're going to see in the code or experience that might show you an underlying issue. Smells that might tell you, hey, we need to do this now, so that when they arise, we can look at the technical debt backlog and find out, hey, we need to do this more. That might be something like if we don't make those administrative screens and we put this out in the field, and then we find out they are changing these items in the database often, and without administrative screens, they have to call into support, and so we waste support time doing that. After we do that, we can validate how much that costs us. Each one of these calls is about an hour. We have a $100 rate for support. We get about 50 of these a month. We can then calculate how much money that costs us. So if it is only going to take $2,000 to implement the admin screens, that's worth it because it will save us so much more money in the support costs. That's when a technical debt item comes to fruition and you can actually implement it on your backlog. Sometimes it'll never come to fruition, and then you'll know, well, that was something we thought we might have needed and we didn't do it. And that way we didn't introduce complexity that we didn't need. But you want to make sure you do address it, that it's not just something that gets swept under the rug, because a mountain of technical debt will make a very poor quality product, and that will cause much more headaches down the road. So in Agile concepts, we talked about something called continuous deployment. A key factor in that is continuous integration. The idea that the second I build something, I'm integrating with everything else I'm already doing. This is usually an engineering environment we set up. And what that means is, as a developer, I write a piece of code, I check it into source control, a server picks that up and builds it with everything else that's been checked in by all the other teams and all the other team members, and can immediately tell me if I broke something. That way, if the build breaks, we can get an email, there can be some notification through our icon tray or something like that. Some way we tell the team the build is broken. And then we stop and we fix that build. We want to make sure that we don't leave that build broken for a long time, because then there might be even more effort downstream to get everybody's code working together. Second the build breaks, we go and fix it. I've often been in places where if you break the build, you have to wear the hat of shame or the cape of shame, something that makes sure you're never going to do that again. Now, it's going to happen, and understand that it will happen, but make sure you resolve it as fast as possible. Continuous integration can go beyond that, though. As soon as it's actually built, you can actually run unit tests against it. And that way you know not only does it not break any of the actual code and the build, we know it doesn't break any of the existing functionality we have under tests. Not only unit tests, but you might be able to set up automated regression tests for the feature test or user end testing. Not only do I want to have automated builds, but I may want to have also automated deployments, scripts that are going to move this build and this application into one environment or another. That can be just scripts, it can be a setup application, anything like that. And the more we can automate that, the better, because if you have different environments and different ways of deploying to those environments, then when you have an error that's on one environment and not another, it's hard to say, is that a configuration error, is it an environment error, is it an actual error in the code or not? Tracing those down takes a lot of time. We want to get rid of that. Make sure your environments are as close to each other as possible, and that the way you deploy to those environments is as close to each other as possible, so then you rule those out and you'll save yourself a lot of time. Another very popular engineering practice in Agile is test-driven development. You can do this outside of Agile, but Agile communities have really picked it up. And what this is about is writing your code through tests first, and then making that test pass, and then refactoring it a bit. So you'll often hear this called red-green refactor, where the red is write a failing test. Write the code that you want to actually consume, but it won't be there yet, so it'll fail. Then write just enough code to make it pass. This is usually called red and green because most of the tools you do this will have a red for a failing test, green for a passing test. And then once you get that test passing, then you can go back and refactor and tweak that code and make sure that it adheres to all your coding standards, and you aren't repeating yourself any place, and you're doing good reusability, all these types of things. And you're confident in doing that because the second you make those changes, you can just go run your test again, and it will tell you if you broke any of the existing functionality. And this not only is great for testing, but it also changed the way that I actually started writing code. I used to be a very database-centric person, and I'd write all my database first, and then all my data access, and then my business logic, and then my UI. Kind of built from the back up. And test-driven development actually makes you think of the consumer first and work backwards. That way, I was always writing just what I needed to get something done, and not adding a lot of extra to it. It helped me think about my APIs and how I made calls in and out of this software, and I was a much better developer for writing that way. And as a benefit, I now had tests that at any second time I wanted to run these tests, I could make sure that the entire application was still operating the same way I thought. This has become invaluable. I've been at places where I worked on one team and an offshore team was working on the same code base on another project though, and I wasn't even aware of them. Wrote all my code using tests, and then I came in the morning and my tests were failing. I knew I hadn't changed anything, and I didn't know that anybody else was. After I investigated, I find out what code was broken, could look in source control, and I found out there's a whole other team working on this. I engaged that team, made sure we started having some collaboration between us, and then that cut down on those type of breaks. But I never would have known that until much later if I had not been using test-driven development. Test-driven development and unit testing are not the only types of tests out there. Unit tests are about testing small, succinct modules of code, and you usually do what's called mocking around it, making sure that you set up the context around it to where I can know what goes into that module and what I expect to come out of it. But then you need to make sure all those modules work together. That's usually called integration testing. That's usually a little bit harder to set up because you need sometimes test databases that need to be populated with correct data. You might be interfacing with external services and you either need to mock those up or have test services. But these are well worth it because even though all the modules can be doing exactly what they need to be doing individually, sometimes quirks come in when you actually connect them together. So integration tests are a good way of doing automated tests as well. You may also want to do automated feature tests. These are from the user perspective, consuming a UI. There's a lot of frameworks out there that will help you do this, that will allow you to automate and instrument these tests. So manual testers will go through these tests and record them, and then they can play them back. Through these different levels of test, you should get a good amount of coverage of your code, and you can usually use tools to show you what code's not covered and make a decision of, do we really need to make sure there's a test for that? And sometimes you want to have 100% code coverage, and sometimes you want to get a good, decent amount and make sure the code that's not covered is not critically important. But you want to make sure you do have certain levels of all three of these tests. That way, when you need to retest things, it can be as automated as possible. Almost always there's going to be some use of manual testing, and in some cases you need more than others. If you have hardware or anything like that, you really can't simulate that. But if you automate as much as you can, you're going to be able to move much faster because as soon as I make a change, I can tell if I broke anything else. And it does all your regression testing for you as much as possible. Another concept is the definition of done. And this is something that needs to be agreed upon by the whole team. I've been on teams where we started working on something. Somebody says, hey, I'm done. And we said, well, did you do this, this, or this? And they say, no, I didn't do that. And we said, well, then it's not done. So then they come back and say, now I'm done. Well, did you do this or this? No, I didn't do it. So now we have done. We need a succinct definition of what it means to be done so that when somebody comes to you and says it's done, you're sure all these things have been done. This could be different per team, per project, per technology, but generally you might have something like, I need to make sure that there's some artifact with some design elements in it. And whether that's a napkin, a Visio diagram, doesn't matter. You need to make sure that it builds on a server and not just on the developer's box. You need to make sure that all the tests are passing, whether they're automated or manual tests. Any documentation that is required of you for the end of the sprint, whatever needs to be done. Document that, print it out, put it on the wall, so when somebody says it's done, everybody has agreement of what that is. That will help make sure that you're not running into any surprises at the end of the sprint, and everything is done according to what you've set in place.